I don't know how familiar you are with PC11, but the PC is proposed C category, and then it's going to be the 11th change. So we've been through PC1, 1.5, 2, 3, 4, 5, 6, 6.5, 7, 8, 9, 9.5, and we're now on API CJ4 is, or was PC10 when it was being developed. So PC11 may become CK4, but that will be decided by API at some later date. But the requests from the Engine Manufacturers Association for this new category, they've requested an improvement in oxidation control. They've requested a possible enhancement when running with biodiesel. They've requested an improvement in the shear stability, and that is something that I can talk about. When we formulate a multi-grade oil, we put polymers into the oil. These are called viscosity modifiers, and they're large organic molecules. So they're sort of like an oil molecule, but they're thousands of times bigger. But they're hydrocarbons, and they're long chains, and they have characteristics such that when the oil is cold, they sort of collapse on themselves, and as the oil gets hot, they expand and they entrain a volume of oil and make the oil appear to be more viscous than the base blend of the oil would be without the viscosity modifier. And because these polymers are so big, it's actually possible to break them. Well, and when you're thinking about these viscosity modifier polymers, essentially every time a set of these gear teeth meshes, there is a possibility that one of these polymers can get caught between the teeth and it can break. And historically, I mean, this has happened forever. Some polymers are smaller and they're what we call more shear stable. Others are larger and they're less shear stable. And there are economic trade-offs and reasons for going for larger and smaller polymers. But historically, what has happened is engines have put 4 to 6% soot in the oil. So what would happen is the engine would run, the polymer would shear in these gears, but the soot would cause a viscosity increase because you're putting stuff into the oil. So in an oil drain period, what we would typically see is there would be a little initial shear, and then kind of the shear and the soot would be, they would sort of offset each other, and there'd be a long period of time with very stable viscosity control. Well, with the new 2010 emission configuration engines, we're putting very, very little soot into these oils. And these oils are formulated to handle 6, 7, 8, 10% soot. And so you're not getting a viscosity build from the soot. We are continuing to break the polymers, and there have been some incidences where oils are actually dropping out of grade from an SAE 1540 to a 1530 under some operating conditions. One of the requests of the EMA is they'd like to address this. They haven't said it's unacceptable, but they would like to look at it and see if perhaps by changing the way we test for shear stability, we can improve the performance of oils in these engines going forward that are going to have very, very low levels of soot. And by the way, another thing is that this is a relatively older design. As engine designers are changing the designs of their newer engines, they're going to what we call high contact ratio gears, which means on the same pitch diameter, they would put about half again as many teeth. So there'd be smaller teeth. So each revolution is going to have many more meshes, much bigger chance of shearing the polymer going forward. So a combination of low soot, high contact ratio gears and a very high probability that you're going to shear the polymer going forward. It's just the fact of life.